Okay. Please, can you see my the sandbox?
Yes, Edward, it looks very nice now.
Thank you, Ken. Okay, so this is an area of interest that we want to work with. It's actually a river basin. Using the coordinates, I've been able to extract those areas that we'll be working with. And the product that I'm using is the annual geomedian. So normally we use the dc.load or the load ARD to load the data sets from the database onto the sandbox so that you can actually start manipulating it at your end. So what we see here is the DC, which is actually called a variable. And when we load the data sets, they will be stored within this DC variable. So right now, I've loaded the time series from 2017 to 2020. So how do I investigate these data sets that I have loaded it up? That's when I come to the next cell. In the next cell, I will type the DS. So once I type DS and I run it, it will give me the results, the database, the data that I requested from the area of interest. So looking at the dimension, the time series actually tells you the time step that was returned. Because I requested from 2017 to 2020, and the product that I requested was an annual data, we are going to get a yearly return. So the time step here starts from 2017, 2018, 2019, and 2020. And the X and the Y is the pixels that were returned for us. Going through, you see the data variables that was returned. Within my measurement, I only specified blue, green, red, and near infrared. So that was why we had these values returning within the data set. So normally, depending on the measurements that you want to work with, if you specify them within these measurements, they are just going to be the ones that will be returned for you. If I would have just specified the blue and the green, which we can actually do it now. Once I run it, then I click, then we inspect the data set again. You notice that only the blue and the green variable was returned. So depending on the measurements or the type of indices or the type of calculation that you want to do, you can actually restrict the type of measurements that you want to work with. Because of what I want us to do with this one, I'm going to use the near infrared and the red. So once I specify these ones and I run it, it is done, then I load the data sets. You know that depending on how I arrange it, that was how the data variable set has been loaded at this particular session. Right now, we have the data at our end. We have it display. How do we interact with the data? The Digital Earth Africa actually makes it easier for you to be able to visualize the data, to actually see the end results of the data. So using the RGB display, so the RGB function. So the notebooks that we have, anywhere that you are going to see the RGB, that means we are going to display the results of the data sets that we are going to have. So the RGB by default means we want to display the red, we want to display the red, green, and blue of that particular data set that you are going to work with. But mind you, we have 4 time steps. So before we display, one thing that I would like us to do is how do you actually, right now you've selected 4 time steps. Suppose we're only interested in the time step for 2017. How do we actually select that time step from this data set so that you'll be able to display it and see? So this is how we do it. If we want to interact with only one particular year from the return data set that it has come. The first is you call the variable that stores the data sets. Then you use a dot. Then the next thing, because we are interested in selecting the time frame, we are going to use the cell, SEL. And within, you look for the variable that you are after. So the variable we have after here is we have the time, we have the Y, you have the X. But the one that you're actually interested in that can bring out all the results is the time. So you type time here. Then you specify the year. So you specify the year. We are interested in only, we want to bring out only 2018. So sometimes to make it much more easier, it would be best to save it in a variable so that you can actually replicate it and use it somewhere. So because we want to only select 2018, what you do is you just type ds_2018, then equal to. What we have just done is all the data sets are there. You know that it started from 2017 to 2020, but we only want to pick out 2018. And to pick out 2018, we use the cell function to do that. So right now, when we run it and we display the results, 2018, you notice that we only got one time step return as compared to the overall time step, which was 4. But right now, because we specified the year that we are interested, you only have that 1 year return. But you notice that the X and the Y are the same because the region the area of interest that we selected cover the same area. So using the cell, you can actually specify any year you want to work with. So this is 2018. So assuming I want to select only 2019, you will create a variable, name it 2019, then then use the cell, then you type time is equal to 2020. Then let's print the 2019 out. So this is the 2019 variable that we have. So you can have all of them. Then you can be selecting using the cell button. Then you specify the exact year. There's also another way whereby you can also select an image, but this time without using the cell, but you can use the records. All the images are arranged in the form of a record. So instead of using the time is equal to 2020, you can also use the time step, or you can also use the ICEL, where with the ICEL you deal with the steps. So right now with this times, the time steps that returned for the whole of DS was 4. So if I want to use the ICEL, I'm going to deal with the steps. So right now this is 4. How do we do that? So using the same principle, DS underscore, using the same principle, DS underscore 2018. No, let's go for 2017. We want to use the principle of the cell. DS dot, then you use the ICEL. Then the time. When in computer terms, normally computer recognize 0 as a number. So when it actually is telling us a time step of anytime it's doing a counting, it starts from 0. So although the time step that returned was 4, if you want to tell the computer to select the first record for you, you have to go it by 0. So if I do ds.icel, then time is equal to 0. Then we print the DS out, DS 2017 out. You notice that it's going to pick the 2017, only the 2017 for me. If you want to select the last value, that is 2020, because the time step that returned here for us to be able to recognize it is 4. and computer start counting its numbers from 0, then that means the last 2020 is going to be 4 minus 1, which we are going to have ds underscore 2020 should be equal to ds dot I cell into brackets times should be equal to 3. So once we have this one for the 2020, we can run it. Then it will give us the value for the 2020. So the difference between the I cell and the cell is with the selection, it's actually you go with the a value from that particular column. So if I'm picking the time, that means I'm going to go with the years because we are using the annual geomedian. But if you're using the normal data set, that means you have to specify the exact date. But if you're going to use with the I cells, that means you're going to deal with the records. So for instance, because with this particular time step that was returned, we returned 4 time steps. That means when I'm going to use the I cell, I have to know that it starts from 0, then the last time step minus 1 will give me the last one. So if supposedly you went and choose 4, what would happen? Let's run and see what will happen. Because you notice that the time step that came was 4, but you chose okay, so I want to use 4. Let's see what will happen. Let's run and see. Yes. So as you saw, this is the error. Index 4 is out of bounds. Although it was 4, the computer says it's out of bounds. So that actually let us know that although the time step is 4, for the last value is always the last value minus 1, and it always starts from 0. So if you want to determine the last one, it's best to use the 3 to do that. Then we get our time step for that. Please, any question in relation to the I cell and the cell that you would want me to go over it again? Okay, so this is how to interact with the data. But remember, when we're loading the measurements, we loaded blue, green, near infrared, and red. How do we actually do it? If let's assume, okay, with this particular data set, I want to investigate the blue value to see the values that is within the blue, because I've loaded everything here, but what is actually within the blue? So with this one, you have to actually select the particular year that you want to deal with. So from ds dot I cell, let's use the cell. We just specify the time should be equal to, let's specify 2018. The number 2018. Then once you use the additional dot, what you get is the variable that you want to work with. So right now you want to work with the blue variable. You want to see the actual values within the blue. How do you do that? Then I'll specify blue here. Then let's run it. Okay, 2018 has to be in string. So let's make it string here. Then let's run it. Perfect. So I've only selected the 2018 blue band. And these are the values within the 2018 blue band for the geomedian that we had. So if you want to actually investigate the actual values within a particular value, you can actually call it out from here to investigate it. So you can also use the red band here. Then you can print it out. So these are the values for the red band. What about the near infrared? You can also call it like this and also see it. So anytime that you are dealing with various data sets that we've compiled and you want to inspect one of the values, it's best to use the I cell, then call that particular value. Then after that, you call the band that you are interested to work with. Supposedly, you want to change it. So it's okay. I won't go this way, but I want to type ds dot the near infra, the red band dot cell time. Let's see what will happen. You have the same thing. So there won't be any error. So it depends on how you work it around. It will actually give you the same results instead of how you turn it. Okay. Then another question that will come up is supposedly I'm not interested in the red band. So I'm not interested, I won't pick any time band from here. I'm just after the ds.red. Right now, remember that we have 4 time steps. Will it actually work or it will try an error for us? We can just run and see what would happen. So if you don't specify the years, as you can see, it will return all the red bands measurements for you within the geomedian from all the time steps. So if you are interested in actually working with one particular year, you can actually use that. Either you use the I cell or the cell to work. Either use the I cell or the cell to select the year you want to work with. What about if I want to do a division? It's very simple. You just specify the band that you are interested in, then you just do your division. So if I'm interested in red band divided by blue band, red band divided by ds.blue, let's see what will happen. You run it, then it will give you the formula straight ahead. You don't actually have to go through the whole process of if I want to do a division. If you want to do an addition for the image that you are working with, you just specify. So si dot dsi dot infrared, then plus ds dot red. Then you can run it. Then the results will be shown here. So supposedly, if you want to work with a particular function and reuse the function at another area, the best way to do it is to store it in the variable. And the variable should work in such a way that it can be reusable. So ds underscore nir ds underscore nir underscore red should be got. So the variable, you can name it as long as you want. It's supposed to help you to be able to reuse it again. So with this one, we just added the red and and the near infrared bands together. Suppose you wanted to do the division, we can actually also pick up the division and run it here. Right now, we are doing a lot of mathematics calculations, but one aspect of data imagery is to be able to also visualize the image, which is actually the most important thing. So how do I visualize my imagery? The sandbox actually makes it quite easier for us to do it. And with the imagery, because they are small images, you can actually visualize all of them at a go. But there are ways to do it, all of them at a go. But right now, I want to do, how do we actually visualize one image at a time? So suppose I want to visualize only a red band, how the red band look within the platform. One of the ways I can do is I'll just call the DS, then plot. Let's see what will happen. it throws us a question that data set.plot cannot be called directly because he saw that there are a lot of images in it. So the best way to do is just pick one image. So I'll use the ICell here to make it quite easier for us. Then I'll specify the band which I want us to plot. So I'll pick the red band. Then we will plot it. So this is how the red band looks within the data set. Because you are using an image, it's a red band, but because the plot actually uses a hierarchy, automatically it makes it graduates the values behind the cells. It graduates those values for us. So if you want to make it all red, sometimes it has a property called CMAPs. Then within the CMAP, you can tell like, okay, you want red. You want red. Oh, minus well. You tell it that you want reds, then it will print out the reds for us. So with this, you can actually pick up a band, then play around with it and see how you can actually see the results also from it. DA makes it actually easy for us to also work with that, to actually appreciate because right now you're dealing with the red, blue, and green bands, but DAF can make it also quite easier for us if you really want to visualize it in the RGB terms. So that one, we are going to use the RGB. So with the RGB, then you specify the data sets that you want to work with, .I. Then you specify the data sets, .ISL. Then you specify the time, I'm going to use 0. By default, if you don't specify anything, it will just pick the RGB for the 2017 data sets that we've just combined. Then it will plot it for us, as you can see here. The RGB has a lot of parameters. So to get more of you can use the shift tab then to give you all the parameters that is available for us. So by default, the RGB, the bands is red, green, and blue. But you can also play around with it by specifying the bands and changing the color, the bands measurement, depending on how you want it. But suppose I want to display all the time steps that I have that, because I can't be doing one cell at a time because I just want to compare the images that I have. So RGB makes that possible by using the columns. Then within the columns, you specify the common region, the column that is supposed to use. And with this one, I'm going to specify you specify time. So because you want to display all the columns, the selection won't be important here. So you take this one off. And you execute it. And let's see what will happen. So right now I want to plot all the time steps that I have to be able to see the images that is showing. So with that one, when I use the call, you will be able to see that you've gotten the geomedian for the selected area from 2017, 2018, 2019, up to 2020. You've gotten that geomedian there. You've gotten that geomedian there that is shown as you have seen up here. So this is how to actually pick up data sets, work with them individually. And if you want to actually drill down and pick a particular band to see the values behind it, you just call that value name, that band name. After you specify the data, then you plot it out. Also, you can actually do computations on the bands specify the bands, bring the operator that you are interested in, then it will give you the end results. I think we had we did a calculation of the near infrared divided by the red. We can actually also plot that one also out. After you do a computation, you can plot that out. So with this plotting, what you do is you just specify it out, then you just plot. Then it will give you a plot of the of what you are seeing right here. What you are seeing right here. So you can actually do a plot and actually visualize the results of whatever you want to do over time. So this is how you can actually interact with the platform to do further analysis, to see the outcome of the results on how you can actually work on these areas. Please, any question? Okay, so if no question, I would like to bring my the small presentation I wanted us to work on how to interact with the data. I'll bring it, and I'll bring it to an end here. Thank you.